Hello everyone. Today we will discuss about moment, the concept of moment. So we can create moment by applying the external force out of the axis of the rigid body. For example, here we have pipe and we apply the force outside the axis of pipe with a distance of d. So this external force of F not only tend to move the pipe in this direction, but also tend to rotate the pipe with respect to the axis, the rotational axis. So we call this tendency to make rotation as moment. And the magnitude of moment will be determined by the magnitude of F and the distance, which is the perpendicular line with the line of action of force measured from the axis of rotation here. So the moment will be F times d. We call d as the effective distance. So now let's see how we can describe the moment as a vector. So if we apply the external force of F with the point of application here at B, the direction of force is alpha. The angle is measured from the horizontal axis. And we have the point of rotation. The axis of rotation is O. So now how to obtain the moment, the rotational moment about point O due to the force of F. Okay. So we need to find the position of F with respect to point O, with the line O, the rotational axis O. So the position is represented by the factor of R here. But we know that not all F will contribute to moment. So only part of F, which is perpendicular with the axis of rotation, that creates moment. So first, let us extend the line of action of this force and find the distance line measured from the axis, the rotational axis, and this is perpendicular with the line of action. So the magnitude of the moment about point O due to F is F times the distance. And here we need to determine the direction of moment about point O. So we use the right hand rules. The four fingers here follow the rotational movement of the body. And the thumb here describe the direction of moment. So here we have the moment in the upward direction about point O, about the axis O. Okay, so please be sure to always check and obtain the effective distance about force with respect to the point of rotation in order to determine the correct moment. So it is possible to have more than one force on a single body. Okay. Then the first method to obtain the moment about point O is by reducing the forces into single force that we call the resultant here. So by doing this, we only have a single force now. Then just like previously explained, that we need to have the line of action here. We extend the line of action and find the effective distance line so that we can now calculate the moment about point O, which is created by the force of R with the effective distance of D. So it is directed clockwise direction. The moment will turn the body in the clockwise direction. And for this case, we assume that this direction is positive. Okay. So the first way is to reduce the force into single force as a resultant here. Another way, another method to obtain the moment about point O is by calculating each moment which is generated by individual force. So here we have two forces, P and Q. Both of them create moments about point O. So P has the effective distance of small p, and it is rotate the body in the counterclockwise direction. So it is opposite with the previous one, because we assume that the positive is in the clockwise direction, so we put minus here. Then for Q, force Q, it has the effective distance of small q. So the moment generated by this force about point O is this one. So now we can sum the moment from the individual force to find the total moment about point O. And the value, the magnitude, will be equal to the resultant, the moment that's created by the resultant force. So this relation is very helpful in the analysis, and we call this the Varignon theorems. So for example here, we apply the external force onto the bracket, which is hold still on the ground at point O. And the axis of rotation is passed through this point O. This is the axis of the bracket. We apply the external force of 600 Newton at point A. So point A is the point of application here. Okay. Now we can find the moment about point O by finding the effective distance of this force with respect to point O. So therefore, we need to draw a line which is passed through this point O and then perpendicular with the line of action of the external force. So this is our T. Okay. So knowing the geometry of this force and the bracket allow us to find the T. So here T can be calculated by knowing this part. We have two parts here. This part of T is contributed by the height of the bracket. So this part of T will be 4 meters cos 40 degrees. And this part of T is contributed by this 2-meter width of bracket. Okay. So here we have the angle of 40 degrees. Then now we can write the portion of T here is 2 sine 40 degrees. So T will be this portion plus this portion. Okay. So knowing T allow us to obtain the magnitude of moment about point O. Another method is using Varignon theorems. So we will split up the force into horizontal and vertical components. This can be helpful in doing the analysis because it makes it easier. So now as we split up the 600 Newton of force into F1 and F2, now using the geometry observation, we can find that the effective distance of F1 about point O is the height of this bracket. And the effective distance of F2 about point O is this, 2 meters. So using Varignon theorems, we can also calculate the moment about point O as the moment of individual force. So here we have F1 with 4 meters plus F2 times 2 meters. Then we obtain a similar result, same result as the previous one. Okay, so that's how Varignon theorems help us in the analysis. So it is easier to identify the effective distance by splitting up the force. Another method to obtain the moment about point O here is by using transmissibility principle. Okay, so assume that we can move the force of F along its line of application. And first we move this force in the upward position so that the tail will be at P. And this point of P is in the axis line of the rotation. So if we split up this F into F1 and F2, horizontal and vertical direction, so only F1 that create moment here. Okay. So in the other hand, we can also move force F in the downward direction so that it is in the same horizontal line with point O. So here we split up F into F1 and F2. F1 doesn't have distance, but F2 have the effective distance of T2. Then using trigonometry rules, we can find that the T1, the effective distance of F1, if we use the force in this area, then the T1 will be 4 meters plus 2 tangent 40 degree. Okay, 2 tangent 40 degree. And if we find the moment about point C by transmit the force into point C, then we will have F2 times T2 shown here. Both of them have the similar result, the same result. So we can choose one of them. But I suggest to use the second method, which is split up the forces into horizontal and vertical direction, because for specific geometry, it can be so helpful to make the analysis easier. So now let's do the exercise for this.